Let's take a look at a few examples that deal with both impulse and momentum and talk about how we know which formula to use, why, and some of the tricks that are involved. So this question is describing the change in motion, the change in velocity of a baseball as a force acts during a time. This is all about the idea of impulse causing the change in something's momentum. And so this would be a basic formula we would use. I actually, though, like to rewrite this using sort of this idea that the initial momentum plus the impulse tells me what the final momentum is. I just think that that's a better way of thinking about what a change in something means. It means that the initial value has changed by some amount. And so, of course, momentum is m times v. So you could, again, rearrange the formulas a little bit. Please write the formulas down as, in your notes as you best think they should be. Something else I want to notice about this problem, though, is that it talks about a baseball's mass of 140 grams, and that is not our standard unit for mass. So we'll start to see a few grams in some of our problems here. There are 1,000 grams in 1 kilogram, and so we would end up dividing and getting 0.14 kilograms. Now it's a matter of pretty much just putting things in because everything is moving in one direction, and so I don't need to worry too much about the signs, the plus or minus signs of things. I have a baseball that was initially not moving. Okay, it does sort of talk about that in the problem, gives you the initial speed. And then we have a force and a time that is, again, representing the impulse, what's being added to the momentum. And then that would determine the final momentum, again, the mass of the ball times some unknown v. And so we would do some algebra and find out our speed, which is pretty fast. But actually, if this is a baseball pitcher's throw, this is closing in on 100 miles per hour. That's not impossible. All right, so now that ball is heading towards the batter, and the bat is going to exert a force of 1,150 newtons in the opposite direction. So that's a real key phrase there, opposite. When you see something like that, that has to be a warning light that, that negative signs are going to have to be part of the setup here. So let's take a look at what this, how we could do this. We would start with that same idea that the momentum of the ball, which would be its mass times this velocity that we just found, is going to be affected by this new impulse, this new force times a different time. And that will determine the momentum of the ball after it's been hit. So I want you to notice a few things here. Again, that final velocity from the last part of the problem becomes our initial velocity here. We're continuing the story. Also, the fact that the force was exerted opposite to the motion, we've got a negative sign in there for that force. So that momentum is being taken away. Our time, and then again, we're going to solve for the speed. Now this one did actually ask for velocity, okay? Velocity not only includes how fast it's going, but in what direction. So my final answer, I would want to include something about it moving in the opposite direction. And how did I know that? It was because my answer came out negative, just like the force that I had put in to the problem. So I had defined what negative meant when I put that negative 1150 in there. And that helps me interpret what the negative sign means here.